skill is also solving for the volume of cones and spheres. They get their own lesson. Cylinders had their own lesson, and now we're solving for the volume of cones and spheres. So, here's a cone. All right, think of your ice cream cone. And we have a sphere. All right, think of your Earth as a sphere. Last lesson was this guy, cylinders. Now, you're still trying to discover how many perfect cubes fit on the inside of a cone or on the inside of a sphere. Now, last lesson with cylinders, I told you that we still need to know that curvature measurement. So you're probably again thinking, well, a perfect cube, that's why we cube our answers in volume. You want to know how many cubes fit inside that 3D solid? Well, if you look at it, it doesn't really fit because of that curvature that these spheres and cones and cylinders all have. Same with if I were to put this perfect cube on the inside of that cone. Well, it doesn't fit, does it? It doesn't fit. So we got to use pi again today, all right? Remember, that's what volume is that you actually try to discover how many perfect cubes fit on the inside of these 3D solids. So let's go ahead and start off with a cone first. So I'm going to go over that formula and why it works. Let's go ahead and draw one first, best we can. I'm going to draw it upside down. So are you. So we're going to do this. And with up to a vertex. Here we go. All right. The height is right there. And we're going to have it with a radius of 5 centimeters. And the height is going to be 10 centimeters. And again, we want to know how many perfect cubes fit on the inside of that cone. Here's the formula for solving for the volume of a cone. It's 1/3 times pi r squared times the height. Now, when you're solving for the volume of a pyramid, like I taught you earlier, you have to divide it by 3 because when you cut a cube into thirds, it fits inside that crevice of a pyramid. You still got to use that, but this time with the area of a circle, because your cone base is a circle. Then multiply it by the height of the whole cone. So let's go ahead and use some substitution. If you need to, pause, rewind what I just mentioned of why that formula works and why these components make up the formula if you need to. Let's use substitution. So 1/3 times pi times the radius, which is 5, squared, times the height of the whole cone, 10. So this is what we got. Solving the order of operations, you need to solve for exponents first. 5 squared is 25. So now we have 1/3 times pi times 25 times 10. Okay. I'm going to go ahead and do all of that together. Because if you notice that this is all multiplying, when you are multiplying everything, you work from left to right. All right, so if I have 1/3, okay, if I have 1/3 times pi times 25 times 10, and I plug it all in my calculator like this, you'll get 261 and 8/10 centimeters cubed. That's how many cubes fit on the inside of that cone. So again, following the order of operations, get rid of that exponent first and then work from left to right because it's all multiplying. 1/3 times pi times radius squared times height. If you just work from left to right and just plug it all in your calculator, you'll get your answer. Now you could solve for all of this, divide by 3, and then multiply by 10 if you need to. All right, totally up to you, just as long as you work from left to right. That's solving for the volume of a cone. Solving for the volume of a sphere. We're going to draw this guy best we can. Go ahead and draw a circle first, right? And then when you draw the dimensions, I like to use dotted lines to show that it's behind. And I'm going to go ahead and put a center. Remember, every circle has a center. And the radius is going to be, I'm going to say 5 inches this time. Okay, so this again is for a cone. Number 2 is for a sphere. And the formula for this guy is 4/3 times pi r cubed. Okay? 4/3 times pi times radius cubed. Now, 4/3, because if you consider it, watch my pen. I'm not going to draw this, but watch my pen. If you look on the inside of a sphere and you cut it in half and then in fourths, you can discover what the volume is when you divide it by 3. Okay, but you got to do it by 4/3 because there would be 4 sections when you cut it in half and half again. Then you use the area pi r squared, but you got to cube it this time because you are cutting that cube into thirds to fit in the curvature of that sphere's side. Okay? So just trust me with this formula. If you see this on like any type of an assessment, they will definitely be giving you the formula. Okay, I just wanted to explain to you why it works, and now let's go ahead and use substitution with what's given. 4/3 times pi times the radius, which is 5, cubed. Okay, well, let's go ahead and solve for the exponents first, following the order of operations. 4/3 times pi, 5 cubed is 125. And then you multiply straight across. 4/3 times pi times 125. Well, I'm going to go ahead and do this first. 4/3 times pi times 125 is actually 392 7/10. Now, when you are multiplying fractions, you don't need common denominators, but just watch this real quick. I'm going to throw it over 1, multiply straight across. I get 1,570 8/10 divided by 3, and volume equals 523 6/10 inches cubed. That's your answer for solving for the volume of a sphere. Pause and rewind as many times as you need to. Again, they will definitely be giving you the formulas for all quizzes and assessments. I just want to make sure you understand using substitution, rounding properly, and making sure that we're working from left to right because it's all multiplication. And applying that formula properly and knowing that we are labeling our answers cubed because you're actually discovering how many cubes fit inside a cone.